We're doing solving special solutions of linear systems. So what will happen is, what you saw in the warm-up, is that sometimes our lines intersect. When our lines intersect, it's easy to find the solution to a system of linear equations because it's just that point of intersection. If my lines intersect, it means I just have this one point of intersection. That would tell me only one solution. Now, my lines don't have to intersect. If the lines don't intersect, we call them parallel. Since there's no point of intersection, there's no solution then. The last one would be infinitely many solutions. Be careful here, we don't say all solutions because it's not all the points in the coordinate plane. It's all the points on the line, so we say infinitely many solutions. In this case here, the lines are exactly the same, just written in a different way, manipulated. So if I have two lines that are exactly the same, they intersect at every point on the line, which would mean that there are infinitely many solutions. Let's try solving now that we know that these are my three outcomes. Now, in 5.4, unless it tells you how to solve it, you can solve it in any way that you would like. So this first one says, solve y equals 2x plus 1 and y equals 2x minus 5. Now, this one might be one you want to graph right away. Why? Because both these lines are in slope-intercept form. Another very easy and quick one to do would be substitution. I have y is equal to 2x minus 1 and y is equal to 2x minus 5. That means I can substitute 2x minus 5 in for y. 2x minus 5 equals 2x plus 1. When I solve this here, I have negative 5 is equal to 1. That is not a true statement, just like we would do for solving equations. Since this is not true, we would say no solutions. Let's try example number 2 together. Now, example number 2, on your screen, I told you to use substitution and graphing, both of which will work. We can try both of those. Let's first try substitution. So when we're going to do substitution, our first step is to solve for one variable. Let's solve for y in this case. It means I isolate y, so I get y is equal to 2x plus 3. I can then substitute in 2x plus 3 in for y in the bottom of equation. That would be negative 4x plus 2 times 4x plus 6 is equal to 6. Here I have negative 4x. Sorry. I went ahead and multiplied those right away. So if we do 2 times 2x plus 3 when we substitute in y, then we're left with 4x plus 6. So I've got 4x plus 4x minus plus 6 is equal to 6. These two cancel out, so you're left with 6 is equal to 6. What that means is no matter what I substitute in for x, it is a solution to this system. Therefore, I have infinitely many solutions because it's all the solutions are possible here. So when you solve it and get an untrue statement, we say no solutions. When you solve it and get a true statement, we say infinitely many solutions. Now, just be very careful. I skipped a step while I was going through it. Y is equal to 2x plus 3. So when you substitute in 2x plus 3 for y, you get 2 times 2x plus 3. That's how I got 4x plus 6. Make sure you've got it copied down the way I do here. If you solve it, true statement, infinitely many. Let's do one last one together, the word problem. Now you need to draw this diagram down first. These letters are 6y, 2x, 4x, 6y, 9x on the sides, 18x on the top and bottom. The question reads, the perimeter of a trapezoidal piece of land is 48 kilometers. The perimeter of a rectangular piece of land is 104 kilometers. We need to solve the system for x and y. Now the perimeter of the trapezoidal, perimeter means I add all these together. So I have 6y plus 6y plus 4x plus 2x equals 48. For the triangular piece, I have 9x plus 9x plus 18y plus 18y equals 144. Make sure this looks very poorly with how I drew it, but that should be a y and a y. So there's my system. If I go ahead and solve this, I'm going to first simplify those. I have 12y plus 6x equals 48. I have 18x plus 36y, so I'm going to rewrite that as 36y plus 18x equals 144. I'm going to have my x's cancel. Since I have 6, I know I can multiply it by a 3 to get to 18. So I'm going to multiply this whole piece by a negative 3. That'd be negative 36y minus 18x equals negative 144. Now what happens here when I add them all together is I get 0 equals 0. That means that there are infinitely many solutions, which means that no matter what we put in for x and y, there'll always be a solution that makes both these areas equal 48 and 144. Just remember, now we don't have just one solution, we could have no or infinitely many solutions as well. Unless the question tells you what to use,